In this video, we will discuss the problem generate IP address. The problem says that we'll be given a string which will consist only of digits, and our task is to complete the function generate LP, which returns a list of all the possible combination of IPv4 addresses that can be made, and we are given only the string S, and from this string S we have to make all possible valid IP addresses that can be generated from there. So suppose that if we have been given a string which is like 1 1 2 and double 1. So if we have been given a string, let's say as 1 1 2 and then double 1, so there can be two valid IP addresses that can be derived from there. Like one can be like 1 point like 2.2.11. This could be one of the valid IP addresses. Like we can see here 1.2.11. This is an IP address, and another IP address could be like, it could be like 1.1.21.1. okay, this could be another IP address. Now another IP address could be 11.2.1.1. okay, you can see that. So basically there will be four IP addresses. You can see 11.2.1.1. now another IP address could be like 1.12.1.1. So these are the four valid IP addresses that we can derive, not two but four. So these are the four valid IP addresses that we can get from the given 11211 like string. So our task is to generate all the valid IP addresses from the given string. So how can we do that? So basically, if first of all we consider that what is an IPv4 address. So basically IPv4 is nothing but it consists of 32 bits, right? It consists of 32 bits, and as you can see it has four parts, right? Because you have three dots which separate four different parts, right? So basically in this case what we need to consider is, we need to consider four parts such that every part has equal representation. So all the four parts has 8 bit each, right? And the numbers, like according to this, the numbers can vary from 2 till 255. For the second part also it can vary from 2 till 220 like 55. For the third part also it can vary from 0 to 255. For the third part for the fourth part also it can vary from 0 to 255, right? So basically an IP address is nothing but a 32 bit integer which has four parts. Every part is 8 bit each, and it can be from 0 to 255 for first part, 0 to 255 for the second part, 0 to 255 for the third part, 0 to 255 for the fourth part. 255 is nothing but 2 to the power 8 minus 1. okay, after this what we need to do is, we need to we will be given the string, so we need to get it into some valid part, right? So now there's one more thing. If we consider a case like 132.1.1.1, now this is not a valid IP address because this part is what? This part is invalid, because this part should be between 0 to 255, right? But there can be other scenarios as well. Like in this case, suppose that we write 31.1.1.6. now this is a valid IP address, but 31.1.1.06, this is not a valid IP address, because in the starting of every part we should not have any trailing zeros. Since we have a trailing zero here, so this is not a valid IP address, whereas this is a valid IP address. So these are the things that we need to take care of. Now when we think of all possible scenarios, all possible combinations, so from the given string we can consider to form all possible combinations, and we can do that using the process of recursion and backtracking, right? Because if suppose that we have been given a particular string, let's say it was 255, then it was like 111 and then 35. okay, so what we could have done here is, let's see, can we make we can make the first part as just 2, right? We can place a dot here, so we can just make it 2, or we could have placed a dot here like in the second after the two parts, so it could be 25, right? Or we could have done what? We could have placed a dot here as well, so it could have been 255, right? So basically these three parts can be there. Can we make a 2552 from here? No, because that will be out of range. So basically from this part we cannot make it, right? So we'll try to have three partitions on this level, right? After this we can see that, basically you can see that we are trying to consider all possible combinations. So first of all we have put a dot here, then from the rest of the part, now maybe we can try to put 5, and then after that 5 a dot, or we can have 55, or we can have 552, but we cannot have 552 because it is out of range, right? So basically we can try to check all possible scenarios using the process of recursion and backtracking, because in this way we will be able to find valid and invalid combinations. Like suppose that in place of this 255, if we were given like 250 something like 257, so if we have a 7 here, so can we have a 257? No, we cannot. So in that case we would have returned that okay, this is false, this is not true, so we would have not checked in the end. And when will like in this case when we are checking using recursion, so when can we say that we have made a valid IP address? So suppose if we are able to divide it in such a way that, suppose that we do this thing, suppose it was 255 only, right? So if it was 255, we put a dot after that, and we put 255 then dot, and then 111, and after that 35 and then dot, right? So like we can see that if we are able to put 3 dots properly and after that we reach the end of the string, in that case we can simply say that we are able to generate it and we'll simply store it as the answer. Otherwise, if suppose that we put the dots in such a way, like if we put the dots in such a way that even after that we are getting more characters, like if we put a dot here, if we put the second dot here, if we put the third dot here, if we put the fourth dot here, right? So basically even after putting these many dots, right, if we, like we can see even after putting these dots we are getting much like a larger part, so that's why it's invalid. So basically we can do this using recursion and backtracking. But there is a much better way, because if you will see, so we are basically doing like if there is a complete part given, right, and we have to do convert it into 4 parts. So if we do three different partitions, then we'll get the first part, right, we'll get the second part, we'll get the third part, and we'll get the fourth part. So basically we can try and think of running 3 different loops, right? Because if we have been given a particular IP address, let's say if it is like 1 1 2 and then double 1, so we can have maybe one partition here that can be ith partition. Let's say we have another partition j partition here, and we have another partition k here, right? So we can try to develop the partitions in such a way that in this part, like this is the middle part, right, of the partition, this is the second part. So for this part, like if I expand it, so it will be what, 1 1 2 and then 1, right? So basically there is a dot here, there is a dot here, there is a dot here. So this is, let's say, I, this is, let's say, j, and this is, let us say, k. Okay, so if I am trying to develop this kind of a thing, so first part is this one, right, second part is this one, third part is this one, fourth part is with this one. So basically we can try to check individually for each and every substring. Like this substring will be from 0 till I, right? This will be from I plus 1 till j, right? This will be another thing between j to k, and this will be from j to, this will be from k till n, right? So for each and every part we can check this numerical value. If they are having some, like if suppose that this was the last part, okay, and suppose that after k you had got the last part, last substring, and it was like 0 and 6. So if it started from this 0, then it becomes invalid. So we can definitely return that this will not be possible, and we can return a false from this side, right? So basically we can try and check, and if suppose that this was valid, if this was not a 0 and there was a 6 only, so we can see that all the 4 parts are valid. So in that case we will generate this particular IP address and we'll send it and we'll store it, update it in our final answer, right? So that's how we are going to do it. And the time complexity for this approach, because we'll be applying 3 loops, so that will be nothing but order of n cube, and the space complexity of our approach will be nothing but order of n, because we'll be storing the answers in a list, right? So let us try and write the code a little bit to see what will happen further. So basically what we will be doing here is, we'll be first of all we'll be having a string, like we'll be having a vector or a list which will help us to return all the answers, all the valid IP addresses that are there that can be generated. So we'll declare first of all an answer. After that we'll find the length of our string. So n is equal to nothing but s dot size. So first of all we'll find the length of our string, and after that like after this what we'll do is we'll simply start our iteration. So int like we'll have we need 3 dots basically in our IP address, so we'll use I, j and k for that. So I start from 0, I is lesser than n, I plus plus. After that we'll have a j loop. So for j starts from I plus 1, okay, then j is lesser than n, and then I'll do a j plus plus. After that what we'll do is we'll say that okay, k starts from j plus 1, then k is lesser than n, then I will do a k plus plus. Okay, after this part is done, so what we need to do is we need to generate the IP addresses, right? Because if we like if suppose that we have this string, like we have suppose 255, then we have 1135 suppose, right? So in this case what we are doing here is we are putting a, let's say, ith dot is here, like I is pointing here, j is pointing here suppose, and k is pointing here, right? So we need to generate this much substring, we need to generate all the 4 substrings that are right there, right? So this is from 0 to I, this is from between I to j, This third part will be from J to K, and this part will be from K till the end. So I'll try to generate all these IP addresses, and I'll check all these four parts, and I'll check whether all these four parts individually are valid or not. If they are valid, then I'll simply store it into an answer and I'll return it, right? So for that, like let's say I'll generate the string st is equal to nothing but generate when I'm putting the dots at the ith position, jth position, and the kth position, right? So I'll generate the generate the IP address. So I'll pass the string s, I'll pass the size n, I'll pass I'll pass j, I'll pass k. This will help me to generate. Okay, now how is it going to generate? So for that, we'll write the generate function here, and it will be returning us a string. So I'll write simply a string for generate function. So string generate. In this, first of all, I'll be passing the string s. Okay, after passing the string s, I'll pass the size of the string, that is nothing but n, and I'll also pass the I pointer, I'll pass the j pointer, that is the first partition point, second partition point, and the third partition point respectively. Okay, after this part is done, so what will I do? I'll simply say that okay, string, the first part, the s1 part will be nothing but s dot sub str. Okay, so basically first of all I'll try to generate the first part, so it will be from 0 to I plus 1, because in this case I'm just using the substring function to calculate the first substring. Right, it is from where? It is from 0 till lesser than I, right? Like basically this much part, like if this I is here, what I is 2, so basically this length of string starting from 0 1 2, so this much part of the of the original string I want to take out, right? So basically I want 255 as the first string, s1. So I'll get it using the substr function in C++, and we can do that in Java as well as other languages using the substring function. Right, after that I'll get the second part, which will be from I to j, right? So like it will be starting from I plus 1 basically. So string s2 will be nothing but s dot sub str, and it will be from I plus 1 till the length will be nothing but j minus 1, right? So in the sub str function in C++, we simply pass the length for which we want to concatenate, like for which we want to substring, sorry, right? So after this I'll also have the sub str for the third part, and it will be from nothing but j plus 1, and the length will be nothing but k minus j. Okay, after this I'll have the fourth string as well. So s4 will be nothing but s dot sub str, and it will be from k plus 1. Okay, the length will be nothing but n minus 1 minus k. Okay, that will be the length of the last part. Okay, after that what I need to do is I need to check individually, because if I have separated them, so suppose if it was like 255, then it was like 13, and then it was 06, right? So basically I have put a dot here, suppose, right? This is the ith part, this is the jth part, right? And suppose this was the kth part. So if I have put a dot, if I have put a dot here, if I put a dot here, if I put a dot here, so I'll check for each part whether each part is valid or not. So I'll check, is s1 valid? Yes, it is valid. Is s2 valid? Yes, it is valid. Is s3 valid? Yes, it is valid. But s4 is not valid because you have a trailing 0 here, right? So it's not valid. Other than this, like if it has a trailing 0, then it will not be valid, but if there was a 6, it would have been valid. But what is the other case when a particular part cannot be valid? Suppose that in this case, if I was having 257, so this will be not valid, because if any part integer value, if it is lesser than 0, or if it is greater than, like if it is greater than the 255, in that case it will not be valid. So I need to write a check function to check for each and every part. So we can basically say that if it will be valid, then only I'll generate the string, otherwise I'll return empty, indicating that with the current partitions as I, j and k, I cannot generate a valid IP address from that. So I'll write a check function here. Okay, so check, in the check function I'll pass s1. Okay, first of all I'll pass each and every string, I'll pass s1, and they will be returning true or false. I'll pass check s1, I'll pass s2, that is the second part, and I'll pass in the check function I'll also pass the s3. So I'll write check function for s3. I'll just write it once and use it every time. So s3, right? And I'll also check the fourth part, that is the s4, right? After, if they return me a true, in that case what I'll simply do is I'll simply return from this particular function s1 plus dot, right? After that plus s2 plus a dot. Okay, after that plus s3 and plus a dot, right? So that is what we'll be doing here, plus dot plus s4, right? So that is what we'll be doing. We'll be generating the string. Otherwise, if it's not valid, then I'll simply say that okay, the string should be empty because it's not valid, right? So we'll not generate a string, we'll not generate an IP address, because if it's not valid, then we'll not store it, right? So if it is valid, then we'll simply generate it and store it, right? So that is what we are going to do here. Now let's quickly write the check function here, and what we'll be doing in the check function is we'll be simply first of all checking. So we can write it as bool, so bool check function here, and in the check function we'll simply pass the string. Let's say s string is passed here. Okay, so in this what we are doing is first of all we'll find the length. So length is equal to nothing but s dot size, right? So once we like we can use the length function here as well. So let's say we find the length using the length function here, right? So after this part we'll say that if suppose that the length is lesser or equal to 0, right? If the length is lesser or equal to 0, or if the length of the current IP address that I have generated, if it is greater or equal to 3, right? So in that case what will I do? I'll simply return a false, because that will not be a valid part, because its length should be between 0 to 3 and not lesser than that, right? Its length should be between 1 to 3, right? After that I'll check if for the trailing 0, right? If there's a 0 in the starting, if s of 0 is equal to 0, right? If there's a 0 in the starting and the size is greater than 1, right? And the size of the string that I've generated, if there's a 0 only, right? If there's 255.255.0.0, right? So that's fine. But if this is a 0, then that's fine. But if after if I have a 0 and 3, so in that case, if I have a 0 and after that I have a 3, so that's not valid, because it should have been 3, not 0 and 3, right? So it will be invalid. So basically I can check for this part also. So if this is another case, in that case also I should be returning a false basically, right? And right after this part what I'll be doing is I'll be making it into an integer. So stoi to check if it lies in the range of 0 to 255 or not. If it does not, then I'll return a false. Okay, so I'll write p is equal to stoi of the string s, right? So I'll convert it into a integer, right? So if the p is lesser than 0, right? If p is lesser than 0, then I can return a false, right? Then I'll return a false, or if or we can say that if the p is greater than 255 also, right? So in that case also we can return a false, and in all the other cases it will be valid, so we'll simply return a true part from it, right? After this part is done, so what we'll do is we'll check the length of the string. So if st.size, right, if st.size is greater than 0, so if we are able to generate a valid substring, in that case what we'll do is we'll simply say that answer.pushback, we'll push it back into the answer. We'll push the string st that we have generated, we'll push it simply into our answer, and in the end we'll simply return our answer from here. So we'll simply return our answer. Now let us try and compile this code to see if there is any error that we might have committed here. Okay, so we are getting some errors here. Okay, so we have not written the function correctly, sub str. Let's try and compile it now. Okay, so 1 plus is missing here. Now let's try and compile it. Okay, there are several other errors as well, so we have not declared the types here. So let's write int here, and let's write int here as well. Now let's try and compile and see if there's any other error. Okay, it works on the samples. Let us try and submit this code as well to see if it works on all the other cases. Okay, it does not work properly for some of the test cases, so we might have missed something here. Let's try and check that out. So what we are basically, first of all, what we are doing here is we are basically passing it from 0. Okay, so what I've done here is I have declared an answer, I have got the size, then I starts from 0. Okay, fine, this is also fine. Then I'm passing the size, the n, and this, and if the string size or the string length, I can say if it is greater than 0, then I'm pushing it back into the answer, and after generating all the possible circumstances, I'm simply returning my answer, right? So there is some issue with our code in the checking part either, or in some other part. So we are generating basically a substring, right? So we are generating the substring from 0 to I plus 1, that is also fine. Then I plus 1 till j minus 1, then j plus 1, okay, till k minus 1, okay, and after this the last part we are generating from k plus 1 till n minus 1 minus k, and we are checking if the first part is valid and the second part returns are true. Third part is also valid and the fourth part is also valid. Then we are returning s1 plus dot plus s2 plus dot plus s3 plus dot plus s4. Otherwise we are returning an empty string. So there is some problem with the check function, I think. Let's check that out. So basically in the check function what we are doing is if the length is lesser, okay, if the length is greater or equal to 3, I should have written if the length is greater than 3. If the length is equal to 3, then it will be fine. So this was a basic mistake that I was committing here. If the length is greater than 3, in that case it will be invalid. Now it works on the samples. Let's try and submit it as well to see if it works on other cases. So you can see that our solution was able to pass all the test cases, and the time complexity for our approach will be order of n cube, and the space complexity will be order of n if we consider the list that we are in which we are storing all the possible answers. In case if you understood this explanation, make sure to hit the like button, comment down understood as well. Thank you.